Hello, and welcome to Easy as Pie with Mr. Carpenter. I am Mr. Carpenter, and it's a late Tuesday night, and what better time than now to work on the system of equations review? Am I right? So, please make sure that you watch this video either in its entirety or in the parts where you felt like you struggled most, because this will prepare you for your exam, and I will go over everything in full detail. So, let's get started. The first one really is just assessing whether or not you understand what a solution to a system of equations is, right? So every system has two equations or three equations, right? And all those equations can be graphed on a pair of axes, right? So, right, this is the first equation, and then this one would be the second equation, right? And the intersection points of the systems give you the coordinates that represent the solutions, right? So where they intersect, that's where the solution to the system is, right? So the x coordinate is what x equals, and the y coordinate is what y equals, right? And the more astute among you will notice that these two graphs don't intersect at all, right? Which would mean, that would imply that there are no solutions to the system, right? They don't intersect at any point, so no solutions exist for the system. That's a very simple one. Moving on to number two. Number two is testing your ability to graph, because you do not know at the moment how to solve that algebraically, right? Because it's a quadratic and it's a linear function with a variable inside of it. So we do not have a method for solving this at the moment. We will when we tackle quadratics and polynomials. But right now, what we can do is, since they're both set equal to y, we can just put them in a graphing calculator and use our intersect function to find out the intersection points. Now, the capability of my iPad is limited, so I am not able to show you the graphing calculator per se. Just as a example, I put it on the Desmos graphing calculator. So as you can see over here, I put in the two functions, I graph them, and I can highlight where they intersect. And those two intersection points are both solutions to the system, so they're both answers that should show up in my multiple choice answer, right? So in your graphing calculator, you can either take the cursor and just slide it along and really approximate the solution, right? Because for multiple choice, having approximate is good enough. Or you hit second trace, then you move down to intersect, and you can use that function to find exact intersection points. Find me if you need a more in-depth explanation of that, but hopefully that should be sufficient for everybody. And if you do that, you will notice that your answer is A. Moving on to really the meat and potatoes of this video, that is the actual systems of equations that we're going to solve algebraically. There are 6 of them. There will be 6 of them on the test, and there are 6 of them on the review. No surprises there. Starting with the first one, remember, you can use any method that you want, any method desired, but that does not mean I'm not going to design the questions so that way they lend themselves more to one method over the other. For example, this first one could be done either way. I believe that most students will look at it and go the route of elimination, because that's kind of what we leaned on in class. The variables are all nice and lined up. And in elimination, right, the goal is to add the two equations together and have one variable canceled out. But right now, that's not going to happen, because 1 plus 2 is 3, and 2 minus 3 is negative 1. So neither variable cancels out at the moment, right? Because we need pairs of opposites in order for that to happen, right? 2 and negative 2, 5, and negative 5, 10, and negative 10, and so on, right? So these are what we're trying to build within our system. For example, looking at those x variables, it'd be really cool if that was a negative 2x and not just an x, right? Because then I'd have that pair of opposites and they would cancel out. Well, I can get there. All I have to do is recognize that if I multiply that equation by negative 2, then that will lead me to my desired result, right? So I'll rewrite my second equation, 2x minus 3y equals 3. And then I distribute. Negative 2 times x is negative 2x. And there's that pair of opposites I want. Negative 2 times 2y is minus 2y. Minus 4y, my apologies. And negative 2 times 5 is negative 10. Now that I have that pair of opposites, I am more than happy to add them together, cancel out my x variables. Negative 4 minus 3y is negative 7y. And negative 10 plus 3 is negative 7. And if you divide both sides by negative 7, you will notice that y is equal to 1. And once you know why finding x is elementary, you just got to take this and plug it back into one of the equations and solve for the other one. So I'll pick the one that's easiest, which would be the top one, x plus 2 times y. Once again, they're equal, therefore they're interchangeable, equals 5. Right? 2 times 1 is 2. And then I take away 2 from both sides. And x is 3. And we're done here, right? First system is conquered. Second system also very heavily lends itself to elimination. Same idea, right? I would rather this 9 be a positive 18, right? Because then if I add them together, that's a pair of opposites, 18 and negative 18, they'll cancel out. So the question is, how do I get there? Well, I get there by multiplying by 2. Very simple multiplication there. I'll rewrite 2 times 9 is positive 18x, 2 times 2y is positive 4y, and 2 times negative 20 is negative 40. We add, lo and behold, my x variables cancel out. 16y plus 4, negative 16y plus 4y is negative 12y, and 52 minus 40 is 12. Once again, we're just one division away. And y is negative 1. Put that back in, 9x plus 2 times y equals negative 20. 2 times 1 is negative 2. Hold on, what happened here? Yeah, we're good. I thought that it would turn into some gross numbers, but it does not. So we add 2 to both sides. 9x equals negative 18. And then we divide both sides by 9. And x is negative 2. Perfect. Even math teachers are capable of having brain farts. Moving on to the next one, this problem does not lend itself well to elimination. You have to do some extra work to line up all the variables in a nice, neat row like they are here, right? That doesn't really happen in this case. So you can do that extra work to get them lined up for elimination, or you can recognize that both equations are one move away from having a variable isolated. For example, 3y. Let me get the pen. Equals 9x plus 9, right? Well, if I divide every term by 3 and cancel them out, well, y equals 9 divided by 3 is 3x plus 9 divided by 3 is 3, right? And I also could have just as easily gone to this equation and subtracted y from both sides, and now x is by itself, right? Remember, I only need one variable isolated on one equation. And when I do that, I build this equivalency, right? Every time I see a y, I can plug in a 3x plus 3. And that is exactly what I plan to do, right? X plus y equals 19. Well, okay, let's combine terms. X plus 3x is 4x. And let's also take away 3 from both sides. 19 minus 3 is 16. And then we have to divide by 4. Hopefully I didn't lose anyone by doing more than one step there. 16 divided by 4 is 4. So x is 4. Then there's a very easy plug-in here. 4 plus y is 19. So y obviously has to be 15, right? Because 15 plus 4 is 19, right? That's the only way that works. And now we are halfway done. 2 systems left. I'm going to save this one for last because it's by far the toughest. We're going to tackle these 2 first. Starting with the one that's in row echelon form, this one should be a very straightforward one for everyone. Don't overthink it, right? The whole point is that we have one equation with 3 variables, one equation with 2 variables, and one equation with 1 variable, right? And intuitively, you're probably going to gravitate towards the equation with 1 variable anyways, right? Because if it has 1 variable, then you don't have to do any of the substitution or elimination garbage, right? You just go straight to solving. So 4z equals 16, right? I can find out what z is just by dividing both sides by 4. So 16 divided by 4 is 4. So I know z is 4. I got that far. And now that I know that z is 4, I get to move to the second equation and plug in 4 for z, and then I get to solve for y. So I'll do that in green. Negative 7y plus 3 times z. So 3 times 4, right, which would be 12, equals negative 2. Okay, subtract 12 from both sides. Negative 7y is negative 14. Divide both sides by negative 7. And y is going to be positive 2. And now that equation is taken care of. Now I take both variables that I understand and I put them into the equation with 3 variables and I attempt to solve for x, which I will do in red. So negative 5x minus y, which is 2, plus 7z equals 66. All right, let's combine like terms. 7 times 4 is 28, and 28 minus 2 is 26. So negative 5x plus 26 equals 66. We got to take away 26 on both sides, and negative 5x. 66 minus 26 is 40. And then I divide everything by negative 5. And 40 divided by negative 5 is negative 9. No, it's not. It's negative 8. There we go. Negative 8. This is what happens when Mr. Carpenter tries to do mental math at 9:07 p.m. But we've taken care of that one. This one right here is the quadratic system. We cannot use elimination on a quadratic system. We're going to have to do substitution. And this one we can tackle unlike the other one because this second system, this second equation does not have, only has 1 variable in it, right? So, as opposed to this one, right, which has both a y and an x, which if you went in and tried this method, you would get a polynomial with a degree of 2 or even 3, which will require different methods to solve. But we don't worry about that here. I can very easily find out what y is by taking away 5 from both sides. So y equals 25. And then, well, now that I know that y is 25, I can plug that back in for y and solve for x. Okay, and I will do that in green. So 25 equals 4x plus 4 squared, minus 11. And now it's a little bit of review of solving these kinds of equations that may be raised to a power. You cannot take a square root until the base of your exponent is all by itself. And at this moment, it is not all by itself. There is a minus 11 in the way. So I'm going to take a step and add 11 to both sides. So 25 plus 11 is 36. Equals 4x plus 4 squared. Now that the base of the exponent is all by itself, I have the freedom now to take the square root of both sides. And this is the part where a lot of people are probably going to forget something very important. Let's start with the more obvious part, right? When I take the square root of something that's squared, the square and the square root cancel out, right? Because they're opposites of each other. So all I'm left with is the stuff inside the square root. So 4x plus 4. Do not go in and take a second square root and get something like 2x plus 2, right? The square root has already done its job canceling out the square. It's not going to work overtime. When the square root cancels out with the square, you are just left with what's inside. So 4x plus 4 will be on one side. On the other hand, right, I think everyone knows that the square root of 36 is 6. But you have to remember the square root of 36 is also negative 6, right? Because negative 6 times negative 6 is positive 36, right? Every time I take a square root of a number, I technically get two answers. And that makes more sense when you think about this graph, right? If I were to draw this graph, right, this will be some kind of quadratic. So some kind of parabola that looks like this. And this is just going to be y equals 25, right? So that's just going to be a horizontal line. So these are my two intersection points, right? So notice that they'll both share the same y-coordinate because they're the same distance from the x-axis, but there's two different x-coordinates in the solutions. That stems from this right here. That's how we get those two different points. So we take that graph out of the way. Right, so 4x plus 4 not only equals 6, but we're also going to set it equal to negative 6. Okay. Let me erase this real quick to make myself some room. Subtract 4. 4x equals 2. Divide both sides by 4. X equals 1/2. Then I'll do the other one. 4x plus 4 equals negative 6. Don't worry, I will give you more paper to work with, so you don't have to suffer like I do. 4x equals negative 10. Divide both sides by 4. X equals negative 2.5. Right, so 2 answers for x, 1 answer for y. That is what you should be expecting for this kind of quadratic at this stage of the game. Lastly, you know it and you love it. It is the system of three equations. And I actually purposely made this one a little more difficult, so that way you would know that if you could tackle this one, you could definitely tackle the one that'll be on the test, which will be easier than this one. Right? Normally in a system of three equations, right, we label them 1, 2, and 3. Normally you'll be able to find a pair of equations where if you add them together, one pair of variables will cancel out immediately. That does not happen in this system, right? 2, 3, and negative 1, no pair of those are opposites of each other. Doesn't happen with the y's, and it doesn't happen with the z's either. You may be curious to think that it does happen, but remember that negative 3 minus 3 is negative 6, right? They have to be opposites of each other, not the same. So, how do we counteract this? Well, we have to do multiplication, unfortunately twice in a row. So let me add equations 1 and 2 together, and then just see what happens. So that would be 2x plus 4y minus 3z equals 12, and 3x minus 2y plus 2z equals negative 9. And now I have to think, well, which variable will be the easiest to cancel out here, right? If I choose the x's, I'm going to have to multiply both numbers, right? Because I can't multiply 2 by an integer to get to 3. And obviously I can't multiply 3 by an integer to get to 2. So I'm going to multiply them both and turn them into something like 6 and negative 6. And the same thing will happen with the z's. But if I choose the y's, then I only have to multiply one equation, right? Because if I would realistically want 4 and negative 4, and I'm there very easily by multiplying the bottom equation by 2, right? So picking the y variable just gives me less work. It does not mean you're wrong if you choose a different variable or a different path, right? Because I'm tired, I choose the path of least resistance, as most mathematicians do. So let's distribute. 2 times 3x is 6x. 2 times negative 2y is negative 4y. There's that pair of opposites that I want. 2 times 2z is positive 4z. And 2 times negative 9 is negative 18. All right, don't need to concern myself with that equation because I made a new one. We'll add them together. 2 plus 6 is 8x. Y's cancel out. Negative 3 plus 4 is positive 1z. And 12 minus 18 is negative 6. Is it? Yes. It most definitely is. Don't want to make a mistake this far into the recording. So I'm just making sure all my math is correct before I goof something up. But we're good. So now I have one equation with two variables. I'm just going to hold on to this for a moment. Now I need to pick a different pair of equations and cancel out the same variable. So now that I've committed myself to canceling out the y variables, I have to cancel out y again. Well, let me try and add 2 and 3 together. 3x minus 2y plus 2z equals negative 9. And I've already noticed that, well, that's going to be a 1y, and negative 2 and 1 are not opposites, right? I would rather that be a positive 2. So let's multiply that equation by 2 and distribute out, right? And start myself off with what would be something that cancels out. So 2 times negative x is negative 2x. 2 times y is positive 2y. And 2 times negative 3z is negative 6z. And that is equal to 0, because 2 times 0 is 0. Add them up. 3 minus 2 is 1. Y's cancel out as I intended. And 2 minus 6 is negative 4z, and negative 9 plus 0 is negative 9. And this is where I want to be, right? Because this up here, we were doing systems of 2 equations, and hopefully handle those just fine. So with the system of 3, the ideal goal is to turn it into a system of 2 because that's what we're comfortable with. And now I have that, right? I take those 2 and I make a system of 2 equations. 8x plus z equals negative 6. And x minus 4z equals negative 9. And now I still think elimination is the better move here. If I multiply this by positive 4, I'll get 4z and negative 4z, which is exactly what I want to cancel out. So 8 times 4x, 8x times 4 is 32x. 4 times z is positive 4z. And 4 times negative 6 is negative 24. 32 plus 1 is 33x. Z's will cancel out. And negative 24 minus 9 is negative 33. Believe it or not, it all came together in the end. Because when I divide both sides by 33, you'll find that very satisfyingly x becomes negative 1. Negative 1. There we go. And from here, it's just like what we did up there. I know x, I can plug in to find z, and then I can plug those 2 in to find y. 8, referencing that equation right there, 8 times x plus z equals negative 6. 8 times 1 is negative 8. And then I add 8 to both sides. And z is negative 6 plus 8 is positive 2. Okay? Now I know 2 variables. I'll plug them in to find the last one. I'll do that in green, and then we can all have a good evening or morning or lunch or whatever the heck you're watching this. Hopefully not right before the test, but negative x. Be very careful, right? X is negative 1. So negative x would be negative 1. Be very careful with your negative signs. Plus y minus 3z is 0. You guys scoot up there. So negative 1 is 1 plus y. Negative 3 times 2 is negative 6 is 0. Negative 6 plus 1 is negative 5 is 0. And I add 5 to both sides. And that is all that she wrote. X is negative 1. y is 5, and z is 2. And this very long, arduous system has been decimated. So, please take the time to prepare, right? This is one of those tests where either you know how to do this stuff or you don't, right? So practice, repetition, and familiarizing yourself with how you need to pace yourself, maybe which problems you tackle first, which ones you tackle last, is going to be really important for you. With that in mind, please let me know if you have any questions. Have a great day, month, year, life, and I'll